Well, that was the state after the teardown of my 35-year plus old power supply, the first one I ever built, and this is now. Okay, obviously still in a very disassembled state. Um, yeah, just go through it piece by piece. So obviously the power cable, and I can't show you it anymore. It will get a proper IAC connector. The old transformer is replaced. I got that used by eBay. Yeah, see the last mailbag. We'll replace that monstrosity here, which will make it a little bit more portable. I'll keep the analog instruments. I revamped them a little bit with range switches and such. See that video. I will also keep the focus LM317K steel, but it will get a better power, yeah, better heatsink, larger heatsink, appropriate sized heatsink. What else? Sorry. Yeah, that monstrosity will be replaced by, yeah, there goes the focus, by a perf board and bigger capacitors and yeah, especially the rectifier will okay, I fiddled there a little bit, will be get replaced by this here. Yeah, I cut that out from an old processor or chipset heatsink, and yeah, new bridge rectifier, and yeah, the clamp is, it's all very improvised, but it will do the job. Some M3-ish threads cut into it, so yeah, we'll go onto the perf board. I already drilled some holes for the larger components on the perf board. I have two additional relatively big caps, which will, yeah, provide some negative voltage. See how to do that from a single transformer winding, yeah, card link. Already done a video about that, voltage doublers. Some miscellaneous components, oh, out of focus, sorry. Some miscellaneous components, protection diodes, some more decoupling capacitors, stuff. Yeah, of course, 10-turn pot, replacing the old, yeah, thing. It still feels good, but I don't think I want to reuse that one. The old fuse holder, that monstrosity, but it's a nice fuse holder. I will keep it. Will be replaced by something slim and small on the back. I will keep the main power switch. Why not? It's a really sturdy old school switch. I like it. And yeah, in the front there comes a fitting. Let's focus in here. Fitting indicator light. Yeah, with some 3 LEDs and yeah, fitting resistors for them, just to put some basic load on my main power rail, because otherwise the voltage doubler will blow up the main filter cap and probably even more. Yeah, what else? Yeah, of course, the the old really crusty binding posts. That's not really in focus. Yeah, they'll get replaced with some real binding posts, and please don't make fun of the color scheme, because yeah, I was missing a part here on that one, and it's, yeah, it's a nice vintage red. And yeah, these things are also pretty old, and yeah, so I took that part from the yellow one, which will be ground, which will be a completely new edition, and that one doesn't, obviously the earth one doesn't need the insulation sleeve, so yeah, I use the insulation sleeve. It's inside the case, nobody will see it, for the red one, for my plus. Yeah, I already prepped the case for you know, giving it a new paint, and I hope I match the color. Yeah, and this is completely optional. That's a leftover from a build I've done of a, yeah, semi-electronic, no, an electric load switchable, and there will be maybe 2 rods from the back to the front, because I didn't want to touch that anymore, because yeah, there's only very few metal left here in this area, and that makes it really flimsy. So having some struts going to the back and reinforcing it might be a good idea. We'll see. Yeah, and now it's time to put, sorry, perfboard out of view, as are the LEDs, to put it all together. So, let me focus. Not quite. Now, okay. So some, I think, what's that? 1.3K resistors, 2 watts, and LEDs. 3 of them became this contraption, which will go into the old signal light. I simply sawed the end off and pulled out all the contacts. And now it fell to ground. Sorry. Here am I again. And yeah, this will fit just fine in here. And yes, I had to file a little bit on the LEDs to make it fit. It's really snug fit, snaps even. And this is my new signal light, and I wonder, I mean, it's designed for I don't know. Oh yes, I know, it's designed to pull 30 milliamps per LED at 73 volts. Oh, sorry, 73 volts, and yeah, it's not only indication that the thing is on, but also yeah, some basic load on the main filter capacitor, because I will use a voltage doubler. to for negative rail, and then you need some load on your main capacitor. And if you didn't knew that, yeah, have a look at this video about auxiliary negative rails for voltage supplies, power supplies, and yeah. I wonder if this will light up on a 9-volt battery, because I'm not getting out that the second lab power supply I'm working on right now. Yeah, lights up just fine on the 9-volt battery, and yeah, the contacts are not that stable, and yeah, with the dome on it's not that nasty. But well, on 9 volts it will get brighter though, but it's really not bright. It's basically, can I do something here? Yeah, so it's not that bright. It's okay. TO-3 packages have a little bit come out of fashion, but yeah, so you might never have seen in detail how they are installed. There are basically two possibilities. The first possibility is you simply screw it onto your heatsink, but that means that at least one pin, and the third pin on a TO-3 case is the case itself, is connected to your heatsink. And if you don't want that, you have to do some isolation, and there are basically two options for that. You can use these silpads, silicone pads, or you can use, it's hard to grab, give me a sec. A mica sheet. And if you Google for it, there are a lot of discussions about what's better, what has the better conductivity for heat. My take on this is, I mean, this is a classic. It worked for years, for decades. The cheap silpads are probably worse than the classic mica sheets, though there are very good silpads out there with very high thermal conductivity, which probably beat the silpads. Also, using a silpad is much easier, because you put the silpad on and then you're done. With the mica sheet you need 2 additional layers of some heat conductive GUI, one between the heatsink and the sheet itself, and one between the sheet and the TO-3 package. Yeah, but yeah, let's go with the mica, because it's so nice. Yeah, another thing for isolation you will need is these, sorry, I wrote out of frame, these isolation nipples, which will keep your, I hope I put it in on the right side, that will help, or not help, that will ensure that your screw is not touching the heatsink. And these are metric, these are usually 4mm holes. You can look it up, what's in inch. There are some tolerances, but I usually drill 4mm holes. And if your heatsink doesn't come pre-drilled, You can simply use your mica sheet as a template and mark the spots. Obviously had it that way around. Yeah, tape it on, center it, mark the spots, drill the holes, and yeah, make sure you what's the word, camphor your holes properly, so it's really nice and flat surface. Yeah, that's basically all to it, and yeah, you take your conducting goo, heat conducting goo, and you only take, doesn't take much. Only takes very little because it will be distributed by the pressure. You don't need big amounts. And then, if I can find it again, the mica sheet, and you see if I'm pressing here, the goo is already distributing all around. And yeah, about the goo, there is some thermal goo out there, especially for CPU, computer CPU heat sinks, which is electrically conductive. So it has some kind of metallic color. Don't use that, because as you see, the goo will probably come out on the sides, and then you might have a short, and yeah, then all your isolation efforts were for naught. So that should be enough. I also read that stuff is highly toxic for water organisms. Now I lost my holes. One of the pins are slightly bent. Okay. Put some screws in. And here comes another kind of, yeah, washers or no washers. In theory, using washers, which I do, will distribute the force of the screws clamping down the case a little bit more evenly, which will, yeah, result in less distortion of the case from the force exerted by the screw, and so you end up with yeah, better thermal conductivity. So yeah, I use washers. Then on the other side, ooh, these screws are a little bit short, are they? Yeah, let's put at least one on loosely. On the other side, you need washers. when you use isolation pins, because otherwise, I mean, having a metal nut on a plastic torque down on a plastic isolation pin is probably not a good idea. And I'm just making this hand tight, and I have to look. Let's see if that's enough. Of course, you need a cable with a solder lock to connect, and yeah, the solder lock will in itself act as a washer, but yeah. Let's put a no washer on that side. So, and when you torque the whole thing down, try to do it a few turns or half turns, whatever, on each side. Try not to torque down one screw at first with the whole force, because that will also result in some distortion of the case and not so good thermal conductivity. Not that it really matters. Yeah, looks good. So, only thing left to do is to solder on the connections here. Then you solder on the other wires, and you're done. Yeah, well, some heat shrink tubing. I can't live without heat shrink tubing. Yeah, and thing is, if you install it without a mica, or yeah, I cleaned that up a little bit, the excess, without a mica sheet or a silpad sheet, you might be able, depending on the size of the holes, to solder the wires to the pins before you screw it onto the heatsink. But with mica or silpad sheets, that's a little bit hard to do, because the holes for the pins are so small that usually your thicker 1.5 square millimeter or 2.5 square millimeter cables, or whatever for currents you are running through, they won't fit through the holes. So, but yeah, my beautiful LM317K steel mounted onto a more appropriate heatsink. Perfect. So things are starting to progress. Yeah, fresh new paint job. I wasn't that, careful on the inside. That's just to prevent a little bit rust, but yeah, the case is finished. Oh, look at that. Yeah, don't care. It's good enough and it looks much better than before, so it's time to put things into it. Yep, things are progressing. I wired up the primary side of the transformers, so yeah, IEC connector, fuse holder, all nicely wrapped together, and then yeah, to the switch with a nice isolation shield now on top, so no accidental touching anymore. Yeah, that's it. And yeah, the secondary side should go to the board, which comes, yeah, new holes. Oh no, new holes here. These were the old holes from the old transformer. Yeah, nice. So I guess it's time now to put all this stuff, probably not this stuff, but yeah, the small parts onto the board. But I have a plan for this too. So that's a circuit diagram, and well, of course we have some switch, yeah, some connector for the input. We have our, I already showed that in the intro, our, sorry, bridge rectifier. And this is rectifying our AC, and we have our nice big filter cap. And this circuit is almost yeah, out of the data sheet from the LM317K. Here the main power rail is basically connected to my indicator light, which will at most, worst case, draw up to 82 milliamps. And this seems excessive, but I need this load here because I'm running also down here a voltage doubler slash charge pump to generate a negative rail. And yeah, if I can find the diodes, nothing special, 1N4002, and two smaller but not too small capacitors. If you wanna know how these charge pump voltage doublers for generating a negative auxiliary rail work, look at that clip. There I explain it really in detail, yeah, to a fault, like I do. Yeah, and it's probably not absolutely necessary, but two small 0.1 farad capacitors just before my two voltage regulators. This, of course, is the LM317K steel. At the back, we have a connector for that. And down here we have an LM337, which is a negative voltage regulator in its simplest form. And this will provide exactly the minus 1.25 volts I need to regulate that LM317 up here down to 0 volts. Yeah, some output filtering with a smaller cap. Yeah, 10 microfarad caps. It's recommended, so in the data sheet, so we do it. I put them a little bit out of the way. Yeah, and this is basically your voltage divider, which goes to the feedback pin of the LM317K. 91 ohm resistor. Little 20 ohm pot for trimming. And then this goes off board with a smaller connector. Screw terminals, yeah, the cheapest. To my 10 turn pot. Okay, and the values are calculated in a way that I should have always 12.5 milliamps. Yeah, flowing down here back to the negative from the positive rail. Even if the output voltage is 0, we have here minus 1.2 volts. Yeah, and the pot is in that case on 0 ohms, so you have, yeah, you can calculate it. 1.2 ohms, volts divided by 91 ohms plus 20, 0 to 20 ohms. So that's for trimming. So 12.5 milliamperes is always flowing here because below 10 milliamps the LM317 might get into trouble and stop regulating. We don't want to do that. And it's magnetic. Oh, and ignore the EBC here. That's obviously a copy paste from another plan. Yeah, one of the diodes goes here, and there's another 10 microfarad capacitor, which I'm missing. I forgot it. No, I will get it. Is here, and this is also a recommendation from the datasheet. If you have adjustable voltage, just put another capacitor here, 10 microfarad, to help with the transients, or not to help, but to avoid any transients, and have another diode here to help discharge this capacitor, so the input pin, the feedback pin, won't see a voltage that might destroy it or not. Yeah, output filter, another protection diode, and yeah, they say take a 1N something, 1N400 something for it. I will use a beefed up one that can take, yeah, 6A, 60A, so 6 amps continuously, higher peak current, of course, just in case you connect something bad here. And the same is true for this protection diode, which is also beefed up. And yeah, it's just when you look at it, it's across the regulator itself in reversed orientation. So if any high voltage should come in here, is, yeah, shit happens, the voltage can hopefully discharge through your or is buffered by your main filter cap, that big thing here, and go through the rectifier, through the transformer, and back without destroying your regulator. Yeah, that's it. I forgot the screw terminal, And I still have to look for that second 10 microfarad 50 volt cap, huh? Yeah, but now I'm, oh yeah, output terminal. And of course the board. I guess I start now soldering and come back from you to you when I'm done. I almost forgot. I did make a board layout, and yeah, I mean the case is big, so the place I have for the board, no problems there. So yeah, you can pack that tighter if you want to, but yeah, the important thing here is this would be the bridge rectifier, and this would be the negative voltage regulator, and they have some distance in all directions from the big capacitors, simply for the reasons capacitors, especially electrolytic capacitors, don't like it warm. They age if they get warm much faster than they had to, so keep heat sources away from them.